we have the direction that we want to graph the function, and then state the domain. And the first thing that I always want to do whenever I'm graphing these functions is I want to think about what the parent function looks like. And so if we look at example A here, we have a square root function. So when we pick out values for x, we have to pick out values that are going to be perfect squares so that they're easier to graph. So some perfect squares are 0, 1, and 4. I know the answers to those. The square root of 0 is 0. The square root of 1 is 1, and the square root of 4 is 2. So those are for the x and y values. So we graph those. We have our parent function. We have 0, 0. We have 1, 1. And we have 4, 2. And for this, we have to have 4, 8. And -4, -8. And this one we can say is -5 and 5 for the coordinates plane. So our parent function looks like that. Now what this says is there's no transformation. There's no h under the radical and there's no k after. So the only thing is we're worried about is a vertical stretch. So when we're talking about that, that means that we're going to multiply all of the y values by 3. So 3 times 0, that is equal to 0. 3 times 1, that is equal to 3. And 3 times 2, that is equal to 6. So we have our new coordinates, which are 0, 0, 0 for the x, 0 for the y, 1, 3, and 4, 6. Those are the new coordinates. 0, 0 is the same as it was because there was no transformation. The only thing that happens now is we have a stretch. So over 1 up 3 and over 4 up 6. So then we can do a sketch of what the graph looks like. And we know, remember from this spot, 4, 2, this was a value of 2 off the x-axis, and now we have a value of 6. So we stretched it at the spot x equals 4. We stretched it a vertical stretch of 3. 2 times 3 is 6. And so now we got to think about the domain and the range for the new function. So we want to use interval notation. So the domain for this one, and we know that interval notation, the 0 is included. So it's going to go 0 is included. And it's going to, for the x, it's going to go all the way. That means that it's going all the way to infinity. Infinity is never included. You can always use set builder, and it just says x is greater than or equal to 0. Now the range, take a look at what the range has here. And the range is similar. We don't have any negative values, so the range is going to start at 0 and go up, so it's going to be the same. We're going to start at 0 and we're going to go up to positive infinity. And set builder is y, not x. Y is greater than or equal to 0. So we take a look at example B. And again, we're going to try to find, graph the function. And then we also want to do the domain and range. Same thing. I want to think about what does the parent function look like. So we're doing a cube root. So I got to pick values that I know the cube root of. And I'm going to start with -8 because I know the cube root of -8 is -2. And then the next one is -1. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And cube root of 8 is 2. So that's the parent function. And so let's do -10, 10, and we can say 5, and -5. So -8 is right there, and -2, and -1, -1, -1, -1, 0, 0, 1, 1, and 8, 2. Okay, so this is the parent function. Curve got a little off there, but that's all right. Okay, parent function looks like that. And now what happens? Well, we take the parent function, we actually do two things. The negative value says we flip it over the x-axis, so everything down here goes up and everything up here comes down. And then we also have a scale factor of 1/2, so that means everything's going to get a little bit closer to the x-axis. So -2 times -1/2 becomes 1. -1 times -1/2 becomes 1/2. 0 times -1/2 is still 0. And 1 times -1/2 is -1/2. And 2 times -1/2 is -1. So the points that we get to plot are -8, 1. So we go over to -8, and then we go up 1. -1, 1/2. So -1, 1/2. 0, 0 is still there because we have not translated up or down or left or right. Then we can have 1, -1/2. So 1, -1/2. And then the last one is 8, -1. 8, -1. And then we do our sketch through the points that we've drawn. And if we think about it out here at 8, we see that this is a value of 1, -1 from the x-axis. And this is a value of 2 off the x-axis. So our equation here, we multiply by -1/2. So 2 times -1/2. So that is -1. That's the difference there. That's the stretch. And if you want to check just to make sure that you have it graphed correctly, again, we can think back to our slope monster. When our slope monster, we have an undefined up and down, and we have 0 defined across. Remember, this is negative and this is positive. We have a negative slope here. So we should be thinking that we're going to start high and finish low. So we're starting high and we're finishing low. So that matches what we remember from our slope monster. Last thing we have to do is the domain and range. And for this, our domain and range is all real numbers. So if we're going to talk about interval notation, we're going to start at -infinity for the x, and we're going to go to +infinity. Or we can say all real numbers. And for the range is the same thing, and all real numbers.